Oh my god. You ever seen an integral like this before? Neither have I. Well, in case you're wondering, I know I'm a year late to this, but this integral specifically went viral on the internet to a lot of mathematicians. This actually started out as a computing disk is supposed to give the first 8 digits of a Wi-Fi password in one of the dining halls from the Nanjing University of Aeronautics, and mathematicians everywhere were like trying to figure out how to solve this. So in today's video, and yes, I said I am a year late, we are going to compute this integral over here. So let's first, the first step, so how do we do this? Well, simple. We can just multiply the square root of 4 minus x squared into x cubed cosine x over 2 and then 1/2. So we get this, and then it's because it's properties of addition, we can just split these into 2 integrals, so that's what I'm going to do here. So I'm going to write x cubed cosine of x over 2, then that'll be being multiplied by 4 minus x squared dx, and then plus, and for the sake of it, because 1/2 is just a constant, I'm just going to move this outside of the integral, so 1/2, then multiply the integral -2 to 2 up the square root of 4 minus x squared dx. So the first integral is like very hectic. You know, you have x cubed, you have a cosine x over 2, and then a square root of 4 minus x squared dx. So how exactly would we integrate this? Because, well, for one thing, you can actually try to integrate this yourself, but like it's going to become very hectic, very messy, and then everything's just going to look so like it's going to be all over the place. So we're not going to use this approach. Instead, let's actually make this observation. Let's make an observation with each function at a time. So observe that x cubed is actually an odd function, meaning if we let f of x equals x cubed, and if we plug f of negative x into the function, we get that it's equal to negative f of x, and then cosine of x over 2. This is an even function. Again, same thing. Plug negative x into here, you get that it's actually the same function. So this turns out as an even function. Cosine functions are always even, so that's just one thing to mention. And then the square root of 4 minus x squared is also an even function itself, because we have an x with x squared, so it's an even degree, so even degrees will always yield out an even function if you're trying to make this observation. So by using these properties, we can do some multiplication here. Cosine x squared times 4 minus x, square root of 4 minus x squared, both even functions. The product of 2 even functions, it itself yields an even function. So with these two multiplied by x cubed, which is an odd function, the whole thing itself is an odd function. So we can make the observation that x cubed cosine of x over 2 and being multiplied by the square root of 4 minus x squared, this is an odd function. And now the last thing to recall is that with an integral of symmetric intervals, so this is going from -2 to 2, the property says that when you have a function that is odd, the integral of the symmetric interval being from -2 to 2 of an odd function is equal to 0. So this means that the integral of -2 to 2 of x cubed cosine of x over 2 times the square root of 4 minus x squared dx is just equal to 0. So now we have one integral out of the, we've solved for one part of the integral. This thing is 0. So now the last part is we can focus on 1/2 times the integral of -2 to 2 to the square root of 4 minus x squared dx. So you might be thinking, how exactly can we integrate square root of 4 minus x squared? Well, we can't necessarily integrate it easily, especially if we were to try using u substitution or integration by parts, or solve it like how you would usually solve for definite integrals. So the easiest way to do this is using geometric interpretations. So recall, obviously, you know, I'm sure all you guys know that the definition of an integral is finding the area underneath the curve. So that's exactly what we're going to do. We're actually going to sketch the curve of this, of the square root of 4 minus x squared. And it comes down, and I'll just apologize in advance, I'm not good at drawing, so if it's off, then oh well. But you get that. The mainly is just understanding the picture. So we have from 0, -2 here, and -2, and then right here, this 2 right here. This, I know, like I said, it's off. I already gave you a warning in advance. So it comes down that the square root of 4 minus x squared is actually half of a circle, a semicircle. And now we're being asked to find the area of this. Well, it's easy, pretty simple. You know, your circle, the area of a circle is pi r square. But because this is half a circle, so it's divided by 2. So the area is equal to 1/2 pi r square. We have that our radius is 2, so we just plug this in. So 1/2 pi 2 square. And then it comes down to 1/2 pi times 4 equals 4 pi over 2 equals 2 pi. So that's just its integral. And now just don't forget to multiply the 1/2. So 1/2 integral, I'm just going to rewrite this integral again just so just backtrack. Dx is equal to 1/2 times 2 pi, and then it's equal to pi. And and now that that's out, and now that we solved that, now we figured out that the whole integral of -2 to x cubed times cosine x over 2 plus 1/2, all this being multiplied by square root of 4 minus x squared dx. This is equal to this 0, and then the area of this plus pi is equal to pi. And we solved it. So pretty much when this integral was viral, the answer it was asking for is the first 8 digits of its 8 digits for the password, and all I can recall is it's 3.114159. I'm missing the rest of the digits. I can't remember the pi digits, but you can look that up yourself, and it comes down that this is the answer. So it's pretty neat integral. At first, it's like it may look a bit like complicated by first glance, but just knowing your properties and then definitions of integrals and all this stuff, especially with understanding what odd and even functions are, then it's actually just a walk in the park, basically. So that's pretty much it. I'm pretty sure I'm the third person to make this video. I only stumbled across 2 YouTube videos who actually solved this integral, but you know, I don't know. I could be wrong. That's all I could find for now. But I could be the third person. I don't know. But anyway, thanks for watching. Feel free to like, comment, and subscribe. I did a video on the existence or the deriving the quadratic formula, so you should check that out too. And yeah, if you actually come across any place that asks for the Wi-Fi password as such as this, then you know the answer is this. So nice. See ya.